Okay, so looking at simultaneous equations for year 12. So the MCAT ones are pretty much still all in play. So there's two ways, actually three ways of solving simultaneous equations, and all are valid. The first way is to draw your two equations on a graph, or on your graphics calculator, but your working would be your graphical image and find that point of intersection. Now that's fine if you can read it off. With a graphics calculator, obviously you can find the point by using your intersection button to find actually what that value is. So algebraically, we want to look at the other two methods, and they are?
Substitution.
Yes, Kella, and? Correct, Ella. Well done. Okay, so let's look at them one at a time. Elimination means we are getting rid of something. So we are trying to get rid of either x or y or a or b or whatever it happens to be in. So if we've got 5x minus 2y equals 8 and 3x plus 3y equals negative 4, all right, this is going to give horrible answers this year. Because last year you didn't have a calculator, they tried to make sure that all your answers were nice whole numbers. This year you have a calculator. And of course you can use your calculator. And we can use our calculator for this method. So first of all, we would put it in our calculator using equation solver and simultaneous equations and degree 2 because there are two unknowns, and put it in there and find the answer before we work it out so that we've got that going on. So if we do it here, we are trying to get rid of either x or y. At the moment, they're not very nice to each other. So we want to multiply both of them by something to enable us to have either the same amount of y's or the same amount of x's. So I'm going to multiply this one by 3 and this one by 5 just because. It doesn't matter which way you do it, it will still end up with the same answer. So I'm going to now have 15x minus 6y equals 24 and 15x plus 15y equals negative 20. All right? Now I've got the same amount of x's. I can just subtract the second equation from the first equation. So 15x minus 15x leaves no x's left. Negative 6 minus negative 15 gives me negative 21y. And 24 minus is adding, so 44. So my answer for y is a very nice 44 over negative 21. Just the sort of number you would like to be dealing with. But realistically, things have solutions like that. In order to find x, I need to go back and put it into either one of my first equations. So I pick the one with the nicest numbers, which is this one. So I've got 3x plus 3 lots of 44 over 21 negative equals negative 4. All right, so somebody's going to work out for me what 3 times negative 44 over 21 is on their calculator promptly and tell me what it is. $132 over 21. Is it 11?
Negative 0.4 over 7.
Negative?
0.4 over 7.
Oh, okay, not 11. Okay. So we are adding it. So negative 4 plus 44 over 11 is 42 is 6. So that's 2 and 2/7, yes? Yes? 2 and 2/7. Negative 4 plus 44 over 7. And then we'll divide by 3 and we'll get the answer. I'm going to grab my calculator because we're not getting very fast on this. So, we've got negative 4 plus 44 over 7. Good, I've got that one right. and divided by 3 equals 16/21. So that's my answer. That is the point where these two graphs intersect. That is the point where these two graphs have an answer that is in common. These graphs could represent all sorts of things. They could represent some sort of manufacturing problem with elephants and teddy bears. And these are the elephants and teddy bears that actually coincide. So we'd have 16/21 elephants, not very many, and negative 44/21 teddy bears, all right? So there's a lot of ways that these can be asked. Okay, the second method was substitution. And as it says, we want to substitute something. Now, this method is a little bit harder because this one can be put into your calculator, all right, using equation solver, simultaneous equations, and variable 2, and then put it into the matrix, you'll get the answer. This one, not so easy. Because you have to rewrite it. Now, you can rewrite it in that form and put it in, but you can also very easily form a linear equation out of this just by substituting. So if y equals that, then this y also equals that. So we're just going to put that into here. 2x minus 4 lots of 5x minus 3 equals 8. And solve for x. 2x minus 20x plus 12 equals 8. Negative 18x equals 8 minus 12 is negative 4. X is that wonderful number of negative 4/18. And because this is algebra, we should simplify it. So it is going to be 2/9. Go back to this one that says y will equal 5 lots of whatever you've just got for x minus 3. So we've got 10/9 minus 3. 10/9 is 1 1/9. Minus 3 leaves us negative 1 8/9. All right, so not particularly difficult. You can use your calculator all the time to do it. Happy? So that was last year, made nasty this year to have nasty numbers. That's all the differences. But in merit, probably excellence, they can introduce something else. So we're still solving simultaneously, but this time their equations may have something to do with non-linear lines. So not lines that have x and y, but lines that have x squareds or y squareds or both. Now, x squareds and y squareds or both introduce us into what's called conics. So in year 13, calculus is a standard called conics. We don't really do it very much here, but it has in it this standard which is all about parabolas, hyperbolas, circles, and ellipses, which for some reason people call them oblongs, but anyway, an ellipse. So solving those. So if we want to solve one of those with each other, we could end up with more than one solution, all right? So in the case of like a circle, let's look at a circle, and we put a quadratic over it. How many solutions have I got? 4, right? 1, 2, 3, 4 solutions. So that's what would come out. We're going to look at one today that has 2 quadratics. So we've got y equals x squared plus, I made this up beforehand to make sure it works, and y equals negative x squared minus 6x plus 8. So the picture of this one, because it's a positive and a negative quadratic, one's going to be like this, one's going to be like that. So how many solutions am I going to have?
2.
Well done. So 2. All right? This one and this one. I don't know where they're going to be. I may not have 2. I may only have 1 if one of mine just touches like that. Or I may have none. All right? So that will come out with that discriminant thing. This is our discriminant less than 0. Equal to 0, greater than 0. But let's have a look. So these 2 are our equations. Generally, we will use this method. So we're saying this equals y, and so does this equal that. So let's put that equal to that. So our first line is going to say this. Right? Make them equal. Now we need to tidy it all up. So I'm going to bring everything over to this side because with quadratics we always make them equal to 0 before we solve them. So we've got 2x squared plus is 11x minus is negative 2 equals 0. Obviously that is not particularly nice, okay? So that Windows doesn't work for that because these two numbers can't get to there. So, and even so, Windows is not really necessary anymore because we've got a quadratic formula. So if we test the discriminant first, just to see whether we have this one, or this one, and how many answers we're trying to find, we've got A is equal to 2, B is equal to 11, and C is equal to negative 2. So we've got 11 squared minus 4 times 2 times negative 2 is 121 minus 8, 16 plus 16 is 138. So the fact that it's greater than 0, 137, good, thank you. The fact that it's greater than 0 means that we have got 2 real roots. Correct. 2 real roots, and that part of this would probably get you merit. So even if you got that far. It's not the question is what are the points of intersection. So we need to now go further and solve the rest of it. So that x equals negative b plus or minus the square root of the discriminant, which we write as a triangle, over 2a. Minus b plus or minus square root of 2a. Okay, so remember to look at your formula off your formula sheet. Make sure you get it right. Pretty sure that's right, isn't it? For some reason I'm doubting myself. I don't know why. Yeah, there you go. So we've got b, which is 11, negative 11, plus or minus the square root of 137, all over 2 times a is 4. They are the 2x values. Right, that's the exact answers. Remember we talked about exact answers with completing the square. That's the exact answers. They're perfect. Horrible numbers. Square root of 137. It's not particularly nice. But now we need the y's. So to find y, we need to substitute the positive one into one of these and the negative one into one of these. So we need a number for this. So we're going to turn this into 2 decimals. We're going to do that by grabbing our calculator and putting it in our equation solver. Good morning. I won't say your name because it will be on the video. Do you want to just sit down? Otherwise you'll be in the video and then I'll have to ask your permission. Right. So I'm going right back to here to find the decimal answers using my calculator so that I don't have to put this horrible thing in. And I'm going to, good, 8, polynomial 2, I'm going to check you, 2, 11, negative 2, 0. What did you say?
0.1761.
Good, 0.1761 is one of them, and?
Negative 5.676.
Negative 5.676 is the other. Now, they're much easier to put in here. So, when we put this one in, we're going to put it right back into here, into one of these. I'm going to pick this one because it's nice numbers, and I'm going to put it in and get 0.1761 squared plus 5 times 0.16761 plus 6 equals, so the y equals 6.9115 for 0.x equals 0.1761, and in the other one, negative 5.676 squared plus 5 times negative 5.676 plus 6 equals negative 54.597 for x equals negative 5.676. So there's my excellence. All right. What is hard? Hard is knowing what you're actually going to do to it. Hard is showing that you know how to do these things. So I've shown lots of things here. I've shown I know how to find the calculator to get these. I've shown I know what exact answers are. I've shown I know what the discriminant is. I've shown I know that there are 2 points, x and y values, that are going to be the solution. One is going to be, so this negative 5 one is way down here somewhere, and this one is way up there somewhere. So those are my 2 solutions that I'm going to end up having. All right? So there are some